Hello, everybody. Tom Morgan coming to you live from Opus IBS here in Suffolk County, New York. First of all, I'd like to say I hope that this webinar finds you well. It's been a tough go the last couple of weeks with the coronavirus, so I hope everybody's doing fine. We're doing our part. I hope you're doing your part. Today's event is brought to you by Opus IBS. We have the ever handsome Chris Martino in the room in charge of production, and the very lovely Gina to help us out with questions later on. Today they want me to talk about some key programming, JLR Key Programming. If you don't know, I am on the JLR Jaguar Land Rover team these days. And our team fields a lot of questions about security modules, in particular keys. Typical problem we have is that someone will come in and say, I'd like to add a key on. And by the time they bring their key in and we push a bunch of buttons, we have a car that doesn't run anymore. So we need to kind of discuss some of the pitfalls of that. So I'll touch on some of the older key programming, which is very simple. Go through some of the key programming of later cars. And then I'll talk about the latest high security module cars that seem to be very problematic. All right, so we have different types of vehicles. I'm going to take this more from a Jaguar standpoint than a Land Rover, because it seems to be that Jaguar is a little more problematic, a little more diverse. Land Rover seems to sort of follow along, but it's all generally the same system. So we'll talk about JLR, Jaguar Land Rover Key Programming. We'll talk about legacy vehicles, what are they, and how to program those keys. Late model key programming with KVM. And then we're going to get into quite a bit of Lin Bus discussion. It's very important to understand that with late model vehicles that have integrated security systems, where we have a key talking to a door module, talking to a KVM, talking to a body control module, talking to a gear shift lever, talk clearly to each other. And the way they do that is through CAN bus, okay, Controlled Area Network. I think a lot of guys out there have heard about it, but don't really know what to do about it. I have a very symptomatic test that we can use to see if we even have CAN bus communication, and how to test whether or not our modules are working. So we'll bump along a little bit here. Okay, different types of communication these days. As of late, I'll start from today and kind of work backwards a little bit. The latest vehicles from approximately 2017 onward are now communicating to JLR through what they call DOIP. This is their Pathfinder setup. What they've done is change protocol, very similar to what BMW was doing with ISTA, Ethernet. They've adapted it or adopted it to JLR. Okay, so now we have a process by which we need to communicate to the car through their Pathfinder. You have to own a Pathfinder device. You have to have a dedicated laptop to control this device, and you have to have certain subscriptions, topics, okay, and of course the SDD Pathfinder. All of this has to be downloaded, okay. Just prior to that, kind of working backwards, is the SDD, symptom-driven diagnostics, and this is where we are right now. This is what we work with a lot today. Okay? The typical cars that are coming into aftermarket shops, if they're going to need help through pass-through programming or diagnostics, I'm doing that through SDD. Okay, this does not require Ethernet. Does not require any other special equipment other than a pass-through device. Okay, legacy vehicles. These are older vehicles, sort of 96 to 2010, and they are what we call the blue box cars. Okay, we can use the AutoLogic blue box to communicate to them very easily, and they do a very good job on the early cars of programming, including keys. All right, legacy on, if we were to plug them into a pass-through situation, put a device in the car and have to go in with any sort of a inquiry or a rescue, this would default to the system that Jaguar used to use, Jaguar Land Rover used to use, called IDS. And this is the old system. Still out there, still working, and it is something we can use if we need to get into a problematic older car. Now, let's move along a little bit. List of security models. As I mentioned here, when we talk about later model cars, we're not just putting a key in the ignition, unlocking the car like an older vehicle. The security modules start with the keys. Then we go to our right front door module, which is detecting that key as you approach the vehicle. We have an RF receiver at the gear shift module. This is a radio frequency device. Okay, it's reading the key. It tells the vehicle that we've entered the vehicle, we've unlocked it, and we have the right key in the car. Now it all goes to the KVM, also known as the RFA, Remote Functions Actuator Module. KVM is the keyless vehicle module. Same thing. All right. They changed the name, I'm not sure, but that's what they do. So now we have this bit of signaling going to the KVM. KVM says, Roger that. We now see that we have got the car unlocked and the proper key in the vehicle. And then now wants to talk to the body control module. It handles the signal and it processes it. This is where our CAN bus comes in. And it says through CAN bus signaling to the instrument cluster that we are going to attempt to start here. The instrument cluster sort of approves all of this data and says, okay, I got the right information, I got the right key, I've got the right unlock sequence going on. Let's allow a start when the starter button is pushed. And of course, the PCM closes the relay and the car cranks, and then the fuel happens, the car runs. But you can see there that if any one of those modules is in default, or the key is incorrect, or any one of those RF signals don't happen, or a CAN bus problem occurs, the signal can't be passed along to the next module. So therefore, we don't have a start. Now, let me just back up a little bit here. Okay. I'm just gonna stop for a second here. All of this is very important. It's all stuff that we need to do. I'm gonna kind of move towards CAN bus a little bit so we can discuss what's happening when the key's not working. Okay, I've done all the programming, I've added the key on, I've done this, I've done that, and still the car doesn't start. It comes up with either a smart key not found or nothing happens when I press the start button. Well, we may have missed a very important step, and we'll get to that in just 1 second. But it's important to note right now that with high security vehicles where you have multi-module systems controlling the key signal, again, the word security is being around here, okay? If anyone could walk into a car and grab a key and program it, they could steal your very valuable car. So rules and regulations have been put in place. These rules and regulations come in the form of what we call an LSID, a locksmith's identification. This is a licensing, okay? And you need to have this, okay? So before you go ahead and program a key or ask Opus IVS to program a key, we need to have this, locksmith licensing information from you. And we get this from you in the form of a D1 form, okay? Let me show you what this looks like, okay? This is a little form that we put together here and asks all the right questions that we need to know. All of this data and the license is controlled by NASTF, okay? And NASTF is the governing body for all of this, and they mandate that you have to have this stuff in order to have a license, okay, I'm sorry, you have to apply through them to get a license. You have to have a license to program security vehicles, okay? All right, this is the other end of the form. This is your NASTF form that you would download to begin the process of getting a locksmith's ID. Okay, there is a fee involved. There's a bit of a waiting period involved, and you have to have this. Okay, I don't want to beat a dead horse, but without this, it's going to get to a point where if you call us for key programming or a rescue on a key program, we won't be able to help you without this licensing. Very important to get this stuff done. I know with Mercedes-Benz, in order to buy many of their parts, you have to have a locksmith license, or you have to have a security license. Okay, this is the other end of the form. Something to look at. Everything that we have for you today, this whole little presentation, it's a bit chopped up, but what we have for you here is available. You can have this, and I'm sure Chris will get this out to you one way or another. Okay. This is a procedure for legacy model key programming. This is the old school stuff. I'm kind of jumping back into key programming right now. I just want to kind of go through this quickly so I can get to a bit of CAN bus with you. This is our legacy model key program. This is the old blue box way. A lot of guys say, how come I can't just put the key in the ignition, turn it back and forth, wait for the little beeper to go off and have my key to work? Well, on an old car, you could. The old PAT system, okay, passive anti-theft system, basically a Ford idea, made it that simple. But this is still open for all sorts of skullduggery to happen for someone to steal your vehicle. So this wasn't very secure. It was kind of secure, all right? Stop it from running. Okay, this advances forward into electronic keys. And when we look at it from a Jaguar standpoint, we see it gets a little more contrived. They ask a lot more questions. There's a lot more buttons to push. But all of this on your AutoLogic tool, if you follow along, can be done. I might take a moment here to warn that using aftermarket stuff, particularly the eBay stuff or anything that's been hung on, pre-programmed to another vehicle, hung onto another vehicle, isn't going to work. So we always advocate for dealer-supplied keys, new, fresh keys from the dealership. Okay, I put some notes in here about keys. It goes electronic, and this is a little later on, somewhere around, I'm going to say 06, 09, somewhere around there. The keys go to electronic. It's sort of a semi-electronic key. Basically, it's the PAT system, but now it begins to call the key the transponder. Okay, this gets a little confusing. Okay, the chip technology is in the transponder. Okay, this is actually the key. Okay, and the remote is for the locking system. So the transponder is for the key acknowledgement. All right, let's see what else we got. These are the steps for late model key programming. I put some dates in here. Let's just move past this a little bit. Okay. All right. Okay, what we have here, let me start from the beginning here. Late model key programming. This is actually something put together by the great Dave Messick, our team leader here at JLR team for AutoLogic Opus IPS. And he basically spells out in this note, okay, in this bulletin, if you will, this is an in-house bulletin, about the procedures that we go through and what we have to do, the step-by-step procedures for key programming. Just having this will pretty much tell you how to program keys, all right? Now I'm going to bump along here just a little bit, and it starts getting into different types of KVMs. So let me see if I can expand on this a little bit. The KVM is not just a KVM. The keyless vehicle module has changed many times over the years since they introduced it, about 2010, 2011. It's probably on its fourth generation right now, okay? But the idea is that there are certain KVMs that won't work with keys or won't work with programming and have to be replaced. In other words, they run their course, we can't get into them. Many of the tools that try to program can't get into them. The only way to get into them would be to replace them and program them with new AutoLogic software, or go in there with a pass-through STD using factory software to program them or recover them. It's just the fact of life, okay? They've changed it, you got to change it. It gets pricey. Later on, as we begin to replace KVMs, we find we have to buy keys also. So now we have to talk about the price of KVM, the price of keys, and in some cases 2 keys, and then the programming procedure. So in this in-house note, it tells all the different numbering system, pardon me, the numbering of the KVMs that you need to look out for. Okay. All right, this is really what I want to get to. All of this is all well and good, okay? Knowing what KVM you have in the car, knowing that you have software available, programming, it's all good, but none of it's going to work if you don't have communication. And this is where we get hung up. Let me just stop the show for 1 second. When we talk to any one of these cars, it's extremely important to maintain peak supply voltage. Now, peak supply voltage to the car is generally 12.6 for these vehicles. When we're programming, it's 13.5. So when we go over to the car and put the battery charger on the battery, we notice that when we go into programming session, we see no battery maintainer applied, or the voltage is too low. How can that be? These cars, many of them, if not all of them, have battery monitoring systems. So when we apply the charger directly to the battery, that battery monitoring system is cutting the charge voltage to only what the car needs. And all it needs is 12.4 to 12.6. So we never get that 13.5 we need, that extra horsepower we need for programming. So it's imperative that we take the negative clamp off the battery and put it onto an engine, chassis, or body ground. Okay? I get a lot of pushback on this. It's important. And you'll find that when you do that, okay, all of a sudden, miraculously, your voltage is where it needs to be for programming. And that's in the area of 13.5. Now, it's also important to know that more is not better. So if you start jacking this thing up to 15, 16 volts, the programming will stop. Okay, the modules will shut down. They're protecting themselves. So we want to find that sweet spot, 13.5, maybe 14 volts, but that's where we want to stay, and that's what we want to maintain when we're programming. Okay, you can make a lot of mistakes if you don't have correct voltage. All right, so let's talk a little bit about CAN bus. Okay, basically what happens here is there's two CAN buses going on here. Okay, there is a medium speed and a high speed. Medium speed CAN bus, just by virtue of its name, is sort of a slower CAN bus. Okay, it doesn't speak at such a high, fast rate. Okay, it's not needed to. It's mostly for body stuff and stuff that's not safety. Okay, like your ABS, your braking systems, okay, or your engine control. So we have medium speed. Now this handles some of our in-car signals. That's very important in order for our ECM to release our car for starting on the high-speed CAN. So they're integrated. All right. So moving along here. This goes on to talk about what CAN is. I have the slide up here, and it's telling us that you know, what we're discussing here and at the rate at which it speaks and what ohms resistance you would be expected to find. We'll get into that in just a second. What I'm trying to explain here is that when we go into the vehicle and when we're talking to the KVM, we're trying to program the KVM, we're talking to some of the in-car modules, we're talking on a medium speed CAN. Okay, and as I said earlier, this all goes to the body control module, which decides, you know, as a gateway module to supply or move these signals forward. At some point, the high-speed CAN has to become involved, because this is what our engine control module is going to be talking on. All right, so we need to know that these CANs are clean and that they're functioning. Let's jump along a little bit. This is an example of high-speed CAN stuff. This is our PCM talking to our TCM, our transmission control module. Now, it's not a signal that we can have go slow or wait for. This has to be moved. These signals have to be moved at a very high rate. Move forward a little bit here. This is a blank screen. Thank you. Okay. What I want to do here is to show, in this picture here, what I want to show you is where we're going to check all this stuff from. Basically, what we're going to need in order to investigate our medium speed CAN or our high speed CAN, we're going to need at least a good meter. Now, yes, scoping these signals is the best way to test it. I find that a lot of people don't have a scope. And if they did have a scope, it's got like an inch of dust on it, and they're not really quick to break it out of the back room, nor do they know how to hook it up. So there is a simpler way, okay? Because since we're always looking for a quick way to get to the to resolve the problem and move on with what we have to do, you know, we want to find out whether or not we have anything going on in the CAN bus. So with a good DVOM meter, not a power probe, a good DVOM meter, we can tell what our voltages are. And basically what we're looking for on these CAN bus signals is a total voltage of 5 volts. Let me explain. You'll have a high side and a low side. Let's just say on the medium speed CAN. All right, you have a high side and a low side. And when we measure these voltages, they should add up to roughly 5 volts. Okay, so let's say we go in and we're going to test our medium speed CAN. I'll explain how in just a minute. And we go in there and we see that we have no voltage on one side and we have some voltage on the other side. Or we have signals that don't add up to 5 volts. Or we have something that's, you know, 12 volts or something like this, some extreme voltage on there. Well, of course, you know, if we're seeing 12 volts or high voltage on there, we know that the CAN bus has shorted itself somehow and picked up battery voltage, and that has to be repaired, okay? If we go in there and we measure our pins, again, I'll get to which pins to measure and how, but if we go in there and we measure our pins at the DLC connector, and we can't get voltage or we can't get correct voltage, we know that something's going on in the CAN bus. So programming is going to be impossible. Okay, in particular, putting keys on it, talking to high security modules would be impossible. All right. So in regards to the medium speed CAN, the typical pins we're looking for at the DLC connector is going to be pins 3 and 11. Okay. Let me just bump this up a little bit for you. I want to go here. Okay. This is a diagram that should be blown up and pinned to the wall of your shop. Okay. Many guys don't know where the pins are. Okay. And when we go into this test, sometimes I get some very obscure answers because we're measuring the wrong pins. So this is your common DLC connector. And as far as JLR is concerned, this is what it looks like. So when we're looking for pin 3, we always know that it's on the wider side. If we were holding this trapezoid up in front of us, we'd know that the high side is on the top and pin number 1 is all the way to the left, and we count over to pin 3. And then it resumes on the bottom at pin 9, and we count left to right on the narrow side. Okay, so what we're looking for here on, let's say, the medium speed CAN, okay, which is going to be pins 3 and 11, okay, shown here in the diagram. What we want to do is take our DVOM meter. We want to set it to 20 volts DC or less, okay? We want to put the black probe to a clean ground. That's important, okay? Then we take the red probe, we're going to stick it in pin number 3, and with the key on, okay, we want to measure voltage. So that's simple enough. So what we're going to do here is we're going to look for a voltage somewhere near, let's say, 2.4 to 2.6, somewhere in the middle of the range, okay? And we'll jot that down. Then we'll jump directly across to pin 11, and we'll make the same test. Again, we need to see the other half of that 5 volts. So if we're seeing 4 on one side, we should be seeing, let's say, 2.6 on the other. That's a perfect 5 volts. We now know that the voltage is good on the CAN line. Again, we're not scoping, we're just measuring to see if we got some voltage. We're looking for the worst case scenario. That's our medium speed CAN. So again, we can run the same test for pins 6 and 14, okay? And what we're looking for here is the same voltages, all right? Now, let's say we have pin 6, again, 2.4. Pin 14 is at 2.6 volts. We have a nice 5 volts. We now know the CAN bus voltage is good. It's good enough to carry a signal, but we still have no communications on some of our modules. Now, let me preface this by saying we've already done a test with our AutoLogic tool, and we can see that we have modules that are not communicating, okay? So we want to get to the bottom of this. All right, so now we've come to a sort of a pocket test for measuring medium speed and high speed CAN voltages. All right. So of course, if we went in there and we saw no voltage, well, something's open. Okay. If we saw extreme voltage, battery voltage, we know that we have a short to a wire somewhere, a voltage wire somewhere in the vehicle. Or if we see something that's really obscure, 1 volt on one side, 1 volt on the other, this is definitely an indication that we've got a bad module. Typically, water ingress. Could be a parking aid module, very common. Could be the BCM or the CJB, super common. On these vehicles, unfortunately, what happens is where they locate the CJB or body control module is typically behind the glove box at the bottom of the A-pillar, which is where our water comes in from the sunroof. Okay, not designed that way, just the way it winds up. And as the water comes down the A-pillar, it flushes through the BCM, CJB, and we now have a destroyed module. Okay, so typically, if we're measuring voltages and we see something really, really low or open, we would probably go to something to one of the common water ingress modules like the CJB. All right. It's also important to know that as time goes by, more and more CAN buses have been added to the system. Same DLC connector, same pin 3 and 11 for medium speed, same pin 6 and 14 for high speed, but now they're using other pins. Instead of having 2 CAN buses, these cars now have 4 and 5 CAN buses. In other words, on the medium speed, they may say they may have had, let's say, 10 modules on a single CAN. Now they cut it in half to lighten the load. Okay, so you now have medium speed A and B, comfort modules, body modules. Okay, and you look at other pins: 2 and 10, 1 and 9, 7 and 15. Right, 16 always remains our power supply. Okay, 4 and 5 always remain our ground. Right? And it's always important to remember that we not only want to see that that DLC connector has battery power, again, that 12.6 that we're for, but do we have a good, clean ground? Okay. A lot of guys skip the ground, and we're looking at power all day long. Can't understand why nothing's happening. Well, you don't have a path to ground. Okay. So basically, what I've told you here is a pocket test for testing to see if we have voltage and what it looks like on our medium speed and high speed CAN, and any other CAN that may be in the vehicle. All right. The other half of the test is an ohms resistance test. Okay, this gets a little more involved, not by much. What we do now is we turn the key off. We disconnect the negative side of the battery. All right, we now take the meter and we set it to whole ohms resistance. Okay, and what we're going to do now is we're going to take our black probe and we're going to take it off ground. We're going to put it in pin 3, and we're going to take our red probe. We're going to put it into pin 11. Okay, we're measuring across the CAN. All right. Now, as seen earlier here, I'll see if I can find that for you. Okay. On this page here, basically what we're looking for is we want to see that this system is operating at 60 ohms. Okay. Basically, what's happening is at each end of the CAN bus, it has a beginning and an end. Okay. So let's say like we're going from the well, let's say the ECM is the beginning of our CAN, and maybe the KVM is the end of our CAN, right? Just make it up as we go along. But the idea is that you'll have a 120 ohm terminating resistor built into the CAN bus line at the ECM, and the same 120 ohm resistor at the KVM, the other end of the line, okay? And these resistors are built so that as the data flows up and down, okay, there's a little bit of headroom. It kind of acts like a shock absorber, okay? So if we were to go in there and read 60 ohms, we could say from our pocket test that we now have correct voltage and correct ohms resistance. The CAN bus is healthy. We still don't have communication. We have to figure that out, okay? But we know that the CAN bus is not the problem. So if we went in there and we found 120 ohms resistance, we know, well, hang on, one end of this system is open, because what the meter is reading now is just one of the terminating resistors. So one of the things we can do here is, if you have available a 120 ohm resistor, 1 watt, you could disconnect your connector at one end of the CAN bus and insert a resistor in there and retest. If it drops to 60 ohms, you found the culprit. Okay. If not, you could reconnect, go to the other end of the CAN bus, put your resistor in there, and try again. What you're looking for is to see what end of the CAN has failed. With this kind of reading, 120 ohms resistance, open terminating resistor, the CAN bus cannot function. So one of our main modules at either end of our CAN bus needs to be replaced. Repaired, replaced, fine. Repaired, a lot of guys say, can I have this module rebuilt? The stuff's expensive. They don't want to buy new, or maybe new is not available, readily available. So they want to go with the repaired module. Fine, good idea. Rebuilt module, good idea. Just make sure it is tested before it's given back, and that some sort of certificate of authentication can be given to you that it has been tested for security and CAN bus. Okay, a lot of times the guys will go in there, fix what's burned, send it back to you for whatever price, and it still doesn't function. So make sure a repaired module is properly repaired and tested. Okay, you also may want to tell these people, if they don't already know, that when you send them a module, it is a security module. So it's talking to other modules in the system. Okay, just want to touch on that for a second. Back up a little bit. Here's meeting resistors. Here's a picture of our CAN high, CAN low. This is the PCM with the terminating resistor in it, and a TCM, transmission control module with terminating resistor. That simple system, if all it did was talk back and forth, is fine. Okay, it's either it works or it doesn't work. But we know that as we go along, a lot of other modules are hung on to this system, okay? And they need to accept their data. So another thing to know about CAN bus is, as we're sending messages up and down the line, each node or module that is on that system is only going to answer its call. So in other words, if the PCM is to send a signal, all right, or a gateway module of some type is to send a signal, it's going to send that signal out so that only one particular module can respond to it. The others will just pass it along. All right. So when we have a situation where we can't pass the information along, this is where we get our no communications. So just to recap real quick, we've gone into our DLC connector. We've run our test for voltage. We've run our test for ohms resistance, and everything's good. Okay. If we wanted to at this point, we can go back into the same pins. We could scope this signal and look to see what kind of corruption is going on there. And this will tell you what shape the signal is in. Okay. So what's going on? What we have to do is we have to understand that there are other modules on the line. So what we can do, and unfortunately with Jaguar Land Rover, unlike, let's say, BMW, where they have a bus bar or a block where we could take modules off one at a time and then reread what's come on to tell us which modules are not talking. We have to go into the vehicle and start testing. So we're always looking for the usual suspects. Okay, I can tell you that on Jaguar Land Rover, BCMs, all right, central junction boxes, are real water ingress module. Rear electronic modules on earlier cars where they use a front and rear module, real problem for water ingress. And any module along the way that is exposed to atmosphere. So that brings up the parking brake module, which on Land Rover is underneath the vehicle. I don't know why it's there, but it is, okay? And what happens is over time, with enough rain and mud, it begins to fail. And that parking brake module is on the high-speed CAN. So if our parking brake module is down and not passing along its CAN message, we don't have our high-speed CAN. We can read good voltage, we can read good terminating resistance, okay, or ohms resistance, pardon me, but we're not passing along the data. So we can go underneath the vehicle, we can disconnect that and retest. Now when we retest with the parking brake module disconnected, if all of a sudden we have our high-speed CAN back, our CAN communications come back up, we found the culprit. That module needs to be replaced, and or the connector and wiring needs to be addressed, okay? Same thing goes for things like parking aid modules. They seem to be placed in an area down in the pocket of the C-pillar on Jaguars, and they accumulate a lot of water. Okay, so we're looking for primarily any modules that would be exposed to atmosphere or water ingress. Now, many of these cars, even new cars, for some reason, very quickly have sunroof drain problems, okay? And those sunroof drains run down the A-pillars, and they're supposed to exit out into the wheel well, but they don't. Over time, they clog up, and we wind up with the water coming in the car. So this is how it runs down the A-pillar and through our modules and kills our CAN bus communication and functions, okay? All right. All right. A lot of times I'm on the phone working with you guys, and you can't see what I'm doing, okay? This is a picture. I thought I would put it up here. This is a picture of STD. This is what the factory stuff looks like, okay? What I'm doing here is showing you the CAN bus test. This is the first thing that happens when we address the vehicle. So here's a scenario. We've gone into the vehicle. We've tried to add a key on, a program a module, and it's not working out. We've gone into the CAN bus system, and we've tested it, and we're pretty sure everything's good. So now we call up for some help, and I've decided to go into the vehicle, or one of the guys on the team has decided to go into the vehicle and look at it using factory software. This is done through a pass-through device. This is our CARDAC 2 and our CARDAC 3 that you hear about, currently built into our latest tool. Okay, those devices come built in. Okay, and we will pass through into the vehicle. So what is pass through? Basically, what we're going to do is let's say you had one of our CARDAC get my terminology right. Let's say we had one of our Drive Pro tools. Okay, these Drive Pro tools come with the CARDAC pass-through device built in. So we could take the Drive Pro, plug it into the vehicle, plug the vehicle into a correct battery source, as described earlier. Okay, and we can plug the whole thing into the internet via a LAN cable. Very important, because we don't want to trust Wi-Fi to drop any packets of data while we're corresponding back and forth. And I can communicate to the vehicle from my desk. And the advantage of this is I now am coming in there with factory software. We're looking at it just like as if we were at the dealer. So I can tell what got missed or what's missing. I can tell if a module, or I can help you figure out that a module is incorrect, or maybe a car configuration. The as-built data is incorrect. These things can be fixed on the spot. Okay, so currently, if we have a situation where one of our tools was unable to do this, we're offering this rescue as a free service. So it's pretty cool. We can tech support's pretty strong in this area and can help you out. But I wanted you to see the screen because this is what I'm looking at. You can't see it because I'm working out of the back of your tool. Okay. When you hear all that dead air and I'm humming along and whistling a happy tune, I'm reading this screen. Okay. And what I really want to see when I begin the test is these green check marks. Okay. Now the question marks are typically modules that are not part of the car configuration, modules that are not fitted. So we're not really too concerned. But if we had a bunch of red X's up here, okay, we would have a car that has a real CAN bus problem. So I would be able to tell right away. Typical phone call comes in. I bought a new key. I programmed it to the car. Now it doesn't start. Or I put a KVM in there. Keys don't work. Or whatever it may be. I go in here. I run this CAN bus test, which is what SDD does first, and it tells me the health of the communications on the car. If I'm not seeing green check marks, we stop right here and we get into that CAN bus test that I was describing earlier. And we can spend some time on the phone trying to find out which modules are not communicating, and I can help direct you towards which ones are most problematic, water ingress modules. And we can come to some sort of determination that we may need CAN bus repair, connector repair, or another module. Okay, we can come back to this and we can proceed with programming. I don't have a lot of screens from it. Basically, this is a identification page. This is the first page. It actually precedes the one I just showed you. But this is our identification page. This is important because sometimes what happens is we'll plug into the vehicle and we can't identify the car. Okay, this is a clear indication that the car configuration is corrupt, or the communications between us here at Opus IBS and your vehicle via the internet is not correct. So we would have to get to the identification page. All right, many times what we'll do is we'll go in there and what I'll do is when this pops up on the screen, you'll hear me read it back to you. And what I'm doing is I'm verifying that we have the correct vehicle. Sometimes, it doesn't happen often, but sometimes we wind up plugging into the wrong vehicle. 2 white cars in the same parking lot. It's happened. Or someone's messed around in there and put a wrong file in there, a wrong car configuration in. We have the right VIN number, but it's not matching the rest of the vehicle. So we can tell right away what's going on. All right, let me just bump back up here a little bit and try to cover some of the stuff I shot through. Again, I think what I'm trying to do here is I don't want to explain who invented CAN bus. I don't want to explain why it exists. I just need to make sure that everybody out there knows that it does exist. And basically, it's a 2-wire system for communication. Okay, all late model cars have this across the board. If you don't have a basic way to understand if it's even functioning or if it's open, the terminating resistor test, you can't proceed. Okay, you can only guess. I sometimes try to imagine what life would be like trying to work on some of these cars without an Autologic or Opus IBS product or the tech support behind it. Yes, that's a gratuitous blurb for us technicians over here, but the idea is if you don't have some of the chops or the tools or the expertise to know the basics, you cannot proceed. Okay, the rest is just a guess. Okay. Before I talked about hang-on models. Okay, here we show the PCM with the terminating resistor, the TM with the terminating resistor. Let's call this the beginning and the end of the CAN line. But in between the two, we have an instrument cluster shown here in an ABS module. When we're diagnosing where our CAN bus message stopped, sometimes what we want to do is go in there and remove a module or back probe our CAN bus. In this case, it's shown as a red and a green wire. Okay, and in this picture here, let's call the red the high side and the green the low side. So if we were to read, let's say 2.6 on our red wire at our DSC connector when we started our diagnostic procedure, and 2.4 on our green wire, we would expect to see the same voltage carrying through the vehicle. So let's just pretend for a minute, okay? Let's say that we are going through the vehicle and we suspect that in this picture here, in this diagram here, the instrument cluster is our problem, okay? We would measure that red wire and that green wire to see that that voltage is carrying through. And if we measured that red wire and that green wire coming out, let's say going towards the TCM, and that voltage goes away, you found your culprit. The instrument cluster cannot pass the signal along. The voltage is stopped with the instrument cluster. It would have to be replaced. Now, in this picture here, it's important to understand the IPC, the instrument cluster, is shown as a through module. If you remove it, everything from that module onward stops. Okay, so you need to be careful of that. All right. If you disconnect it and go to test the TCM for voltage, it won't be there. Okay, because you've removed, you've opened the circuit. So why am I talking about this? If you look at the ABS module in this picture, this is a hang-on module. Okay, this is not a through module. It can be disconnected, and the CAN bus can continue to communicate. Okay, so the advantage here is if we have a hang-on module, we can remove it. All of a sudden, our CAN bus communications come back, our voltage is improved, whatever it may be. CAN bus communications come back. We now know that the ABS module was taking down the CAN bus signal, okay? And we can now replace our ABS module. And I might note that ABS modules on the high-speed CAN is a very problematic module. Again, it's exposed to weather, okay? It seems to be that if the car stays dry, the inside modules that are protected by the body of the vehicle are, they last longer, okay? The outside modules, ABS and like the parking brake module, wind up kind of fading away quickly because they are exposed to the atmosphere. Makes sense, right? Okay. These are the different speeds that the CAN bus talks at. In here, we have some of the typical voltages you would expect to see, and we talked about how they should equal 5 volts. Down here is, oh, I might be prudent to mention there's a Lin Bus and a MOST bus, okay? Lin Bus is basically a 12-volt signal, okay? It's a single wire, typically a single wire signal. Comes out of your module to do one function. It goes from A to Z to, let's say, ask a door lock module to activate from, I'm sorry, a door lock actuator to actuate from a module. Okay. And of course, the MOST bus is our fiber optic network for entertainment. Okay. All right. Let me just bounce back here a little bit. Okay. I'm going to get back to a little bit of key programming here. I wanted to make sure we understood CAN bus because the idea behind that is that the key programming cannot take place without CAN bus working properly. Okay. Too many times I get a call, I can't program the keys on a late model vehicle, and we discovered the CAN bus is the problem. So there's what I was doing. I wanted to make sure we understood how it works. Let's back up a little bit. Okay, let's go back to early model Jaguar. Again, this is a very simple way to program keys. This requires 2 keys, okay? What we'll do is we'll go into the vehicle. We'll put the, using our tool to put it into a program mode. We select program keys from our icons in the key programming. It'll instruct you to put the key in. That identifies the key. This all has to be done within 30 seconds. We turn the key on, we turn the key off, we turn the key on, turn the key off. Very quickly, we get the other key, we turn it on and off until it's received into the vehicle. You'll hear the keys are programmed. Typically, what we'll do is we'll turn the car off, check our door locks, make sure everything's good, start the vehicle. Very simple. Okay. This talks about the early 308 to 350, roughly 2003 to 2006. Subtypes X356, roughly 2006, 2009. Same precautions as the early keys. All keys must be present. This is important. We start programming with keys missing, they're going to be removed. What Jaguar Land Rover does, in particular Jaguar, is when we go to program a late model key or a non-steel key or even a flip key, what will happen is it takes it out of the security module, later on the KVM, and it doesn't exist until you put it back in. Okay, so now we have to make sure that the car is healthy enough, the keys are healthy enough, everything is right, because when we take the keys out, they're gone, and now they got to be put back in. So therefore, any keys that are not present during the session are gone. Okay? It says right here, this is what you'll expect to see on the screen. Keys not present for this procedure will be deleted. Okay? And these should be performed, all these key turns and procedures should be done within 30 seconds. Okay? On the screen, there is a icon. Okay, on the first screen, it shows the number of keys already programmed to the vehicle. This is a helpful diagnostic tool to see if the keys are seen by the vehicle. Sometimes we don't know if the key has failed. We're putting a key in, we're turning, we don't know if it's a key, we don't know if it's a start, we don't know if it's a bad battery ground load, we don't know yet. So one of the things you can do is go into a tool, culprit. All right, there we have to get those keys hung back on or repaired or replaced for the car to start. If we see 2 keys are programmed, you can finish the procedure, try to rehang them on, see if maybe the data just went away from, let's say, a low battery or battery disconnection. Okay, here we talk about later on as the years progress and we move away from solid steel keys, the Tibby key or the flat steel key, and we're moving into electronic keys. The previous keys all use chip technology. Now we're using radio frequency signals. Okay, we're talking to a receiver in the car. Basically the same idea, but the key changes from being a solid mechanical piece to an electronic key. Okay, and it's now called a transponder. There's some confusion there. Some people don't know whether it's a transponder or a transceiver. It's a transponder. Okay, late model key programming. Okay, this is I wrote down here, this is where the wheels fly off the cart and all the smoke comes out. All right, this is what we've been talking about today. These are your electronic keys. This is where the KVM is involved, and we start talking about healthy CAN bus and RF signals, okay? So the procedure starts with, this is from 2010 onward, 2010 onward X351 vehicle and all submodels, okay? It does change a little bit for XF and XK. Some of the cars are still using up to about 09 a key slot. This gets a little confusing. Prior to going to whole electric or whole KVM programming, okay, whole electronic key, it was sort of a partial programming going on here. You program the transponders and the transceivers separately. In other words, the unlock remotes and the key separately. One is done through reading it through an RF signal, putting the keys on the center console, doing your programming that way. The other one is by putting the key into the starter lock, the key dock, if you will. Okay, and this reads the key. Once you've got both halves of that procedure done, you now have a functioning key that can unlock the car. That was scrapped and moved into the KVM type key programming. Not too many of those borderline cars still out there, but you'll have to understand that's basically how it works. When you get into programming, you're doing 2 levels of programming on a single key. One for the key, one for the door actuator. Okay, probably a little easier to describe them that way. One is an RF signal talking to a security module in the vehicle, and the other one is the standardized, let's call it chip, talking to a security module in the car so that they work together. One to start the car, allow the car to start, and one for locking and unlocking the vehicle. All right, here's where we get into the whole description of programming. Let's just to recap a little bit. Basically, what we're talking about these days, what I get many, many phone calls on, is how to program a key. So it's pretty simple. You get the car in, you run the quick test, you see you have CAN bus problems, you resolve them first, you make sure that you have proper battery voltage, okay, very important, and you go into key programming. You're going to request a file for, let's say, a KVM if that needs to be updated, okay? You'll do that first. Then you'll request a file, a separate file, for keys. This is a file to allow the keys to be programmed to the car via the KVM. Basically what it's doing, it's lining up all the software so that the keys can be programmed. Right? In a perfect situation, that works fine all the time. But then sometimes not. Okay, so when we have a problem, either it be voltage or CAN bus, whatever it may be, this is where you can call us up and we get involved with a pass-through key programming. And sometimes this requires replacing a KVM module. sometimes we discover we have to buy new keys. It might also be worth mentioning that as of late, we're noticing that there are two types of late model keys. They're the early and the late, level 1 and level 2, let's call them. If you replace a KVM and try to put a level 1 key on there, it won't work. And this comes up to when you're doing your key push part of the procedure, which is basically identifying or verifying the key to the KVM. It'll tell you to please have the key inside the car, or it'll tell you to hold the key over the shifts around, and you are. It'll tell you to check the battery, and it's good. What it's telling you is it can't see the key. So if you wind up in a situation where you have a late model KVM and you're trying to reuse the customer's original key and it's not working, replace the key with a level 2 key. Pardon me. Some of the data in here that's been written up will tell you all the different KVMs that are available. This is the latest FK72 KVM module that is in the cars that's coming out with newer vehicles. And if you purchased one, this is what you would get. Okay, if you're replacing, let's say, a DPLA or a BJ32, this would require a new key. 99% of the time, we find that the key has to be replaced with the KVM. Okay, back to CAN bus. All right. Well, it's about all what I've got for you here. Let's see if we have some questions. Let's see what we've got. Let's see. I don't understand the first one. All right. Let me go to Victor first here. He says here, Victor says, LSID is an impossible license to get. It is not only intended for individual, it is not intended for individual mobile techs. Well, that's not the way it's described to me, okay? I think you're mistaken there, and I think what you need to do is contact NASTF. This can be done online, and I'm sure that if it's available to you, they're going to sell it to you, okay? Yeah, I would definitely double check that, okay? I think that you need to contact those fellows, because the message we're getting is that if we're getting people calling in trying to program security vehicles, they have to have this license. So therefore, I would think that they're probably ready and willing to make that license available. So maybe a recontact would be a good idea. Let's see. James Vaughn says here, we have had customers take the X351 to deal and have the key programmed after we told them it would need a new KVM to program. Okay. I guess what James is saying here is that they've advised the new KVM and the car's gone to the dealer and the dealer's been able to program it. Not sure what that's about. I would think that anything that they're doing, you should be able to do. And if you're stuck for it, you should be able to call us in and we should be able to help you do it. Okay. As I said, SDD is a dealer level tool. So maybe if you gave us, we could stop that car from going to the dealer. Of course, that's what we're trying to do here. We don't want the cars going to the dealer. We want them to stay in-house. All right, let's see what else we've got here. Victor says, why not a power probe? Power probes are really good for working on boats, okay, because they carry the negative with them and you can test whole systems that way. I don't have anything against power probes. I happen to work on boats. But here's the biggest problem. Too many times we're toggling that button and we send 12 volts to a 5-volt system. And now we've bagged a module. I'm certainly not going to be responsible for that. So I'm always going to advise that we use a proper meter. Okay, the Fluke DVOM meters, any one of them are very good. Even a good old analog meter is good, okay? But I'm shy about power probes because there is that possibility of sending voltage in the wrong direction on a low voltage circuit. People love them. I hear them all the time. I advise people not to use them, and I hear the beeping going on all day. That's fine, okay? It's your choice. Early power probes didn't have a meter on them. The later ones do, so that's a step in the right direction. Still, we have the possibility of sending voltage in the wrong direction. So that would be my pushback on them. Okay, it's all personal choice. Okay, let's see. Stephen Rosen, is the DOIP interface available through Drew? The way I understand it right now, the DOIP Pathfinder that I'm talking about in this discussion is not. Okay, I hope I'm saying the right thing there. But I know right now we have a Pathfinder. We don't get a lot of usage on it, but we do have a Pathfinder device, and that's really the only thing that can be used for doing JLR stuff, through Pathfinder. We have been in a position where we update that thing and we lend it out. So we, if you're stuck in a situation there and we have to do a Pathfinder, pass-through session, we can get you into a loaner agreement, okay, have you sign a loan agreement, and we can lend you that, okay. The CARD Act 3 and some of the later stuff does have some DOIP stuff on it. If the question I'm being asked is, does it work for Jaguar Land Rover, I'm going to have to say no, okay. It's going to have to be Pathfinder only right now. Doesn't mean it won't work tomorrow or in the weeks to follow, okay. You have to remember, we're getting the stuff as fast as we can purchase it, and it all has to be developed, it all has to be tested, and then it's offered on our tool. Okay, right now that's a sort of a new thing, 2017 onward for JLR. Cars are just coming off warranty, and we're just starting to use that device a little bit, but mostly it wants to see that device plugged in, that Pathfinder device plugged in. Edward, so the drive tool has a pass-through device in it? Yes. Rob Wood, we need a pass-through device for key programming. We need a pass-through device for key programming. All right. Oh, I see. I'm sorry. I'm reading that wrong. Why would we need a pass-through device to key program? Rob, I'm sorry about that. The pass-through device is for when we get in trouble. Okay, we programmed the key with a bad CAN bus or something like that. And we're trying to figure out what to do. Sometimes we have a situation where we have a incorrect software. Okay, and we need to go in there and use a dealer software to straighten it out. That's just a fact of life. Okay, we don't have every nuance of every single software. We're trying, and we're trying to have it all. And as I said, the stuff comes out, at will, from the manufacturer. So sometimes we need to go in and rescue, and it requires a pass-through device. Sometimes we need to go in there and see what got fouled up. Sometimes I need to go in there and see that we are actually trying to program with a CAN bus problem. That's why I spend so much time on CAN bus. Okay. Let's see what else we've got. Trying to read my questions here. Bring them up there. There we go. Units use a rolling card as well. Okay. Okay, what's he saying? Procedure for all key lost, please. Procedure for all keys lost. Well, let me see if I can address it this way. If we have a vehicle that comes in and we have no keys for it, okay? First of all, this is a 4-alarm fire. This is the alarms going off over at NASTF, okay? Vehicles coming into a shop with no keys, towed in, no keys. This is a tough situation. The reason it raises so many eyebrows is that, is this car being stolen? How do we know? Okay, so again, we refer back to our licensing and our security modules and what we have to do. So the answer to the question is this: after we can prove that our shop has the licensing to put keys into this vehicle, we would purchase new keys, and they would have to be programmed to the vehicle. In some cases, as I've been trying to put across here, the receiving modules, let's say on a late model Land Rover or a Jaguar, let's pick 2014, okay, 2015, 2016, okay. These cars may need a new KVM along with new keys. So with all the keys lost, we have to reprogram the whole car. Now it can be done, okay. They're begins to be a little bit of a gray area there as to whether or not we're doing it legally. Okay, so if all the keys are lost, sometimes it means a new KVM. It definitely means we have to test the CAN bus. It definitely means we have to do a quick test on the vehicle and see if other modules are functioning properly. And yes, you will have to buy 2 new keys from the dealer. Hope that. All right. So I'm being told that's our time for today. I hope I helped you with some stuff, and hope to hear from you in the future. All right. Goodbye. Thank you.